Logarithms come in handy when we're trying to solve equations like 2 to the power of x equals 23, where we could solve simple ones like 2 to the power of x equals 32, but we can't necessarily solve 2 to the power of x equals 23 without a calculator until now when we're learning logarithms, in which case we can get a solution and it is an exact solution. So example number 1, and we'll go through the process of what we've got to do during this example. So we're going to use logarithms to solve this example here, 2 to the power of x equals 23. So we need to solve it and we're going to give our answers in base 10. So usually in this situation, we're going to use base 10 logarithms. Sometimes we use natural logarithms, but that's a little bit further on. So first step is to take a logarithm of both sides. So take logs of both sides. So what I mean by that is we're going to have log of 2 to the power of x is equal to log 23. So we've just taken the logs of both sides. Now we're bringing the x down the front here. We're bringing that power of x down the front using that log law. So we end up with x log 2 equals log 23. And then it's just like solving a normal equation. Currently, this is x times log 2. So to get rid of it, we divide. So we end up with x equals log 23 over log 2. And that's our final answer in exact form. So just to recap that process, the first step is always taking logs of both sides. Once we've done that, we move that power down to the front using our log law, and then we solve for x from there. So the second example is a little more complicated, and we've got 2 to the power of 5x take 1 equals 3 to the power of x. So a couple of things here. We've got an x on both sides, and the power of the left-hand side is a bit more complicated than just x. But we still take logs of both sides. So take logs of both sides. So I'm going to have log of 2 to the power of 5x take 1 equals log of 3 to the power of x. So again, the next step is to bring the powers down to the front. So we're going to have 5x take 1 log 2 equals x log 3. So from this point, we now want to expand that bracket to get rid of the bracket. So we end up with 5x log 2 take log 2 equals x log 3. Now to solve this type of equation, we want the x's all on one side. So I'm going to do that in the same step. I'm going to move x log 3 to this side and this log 2 over to the other side. So I end up with 5x log 2 take x log 3 equals log 2. So I'll just put in here that we did take and that we're doing plus, moving those over. Then I'm going to factorize. So I need to factorize out the x on this side. So we end up with x brackets 5 log 2 take log 3 equals log 2. So now what I can do, and I'll just go over the page, but you can see that I can move this whole section, this 5 log 2 take log 3 over to the other side to leave the x by itself. And when I do that, it's going to become a division. So I'll just go over the page. So we're moving that over and we end up with x equals log 2 over 5 log 2 take away log 3. Now, you do need to realise that this part of the answer can actually be written quite a few different ways. We could have it written like this. We could then simplify this to log 2 is log 2 over log 2 to the power of 5, take log 3. Or we could have log 2 divided by log 32, take log 3, because log 32 comes from 2 to the power of 5. We could also have another one. We could have log 2 over log 32 over 3. And that fraction comes from the fact that the denominator is a subtraction. So if we use log law 2, when we have a subtraction, we know that it's a division between B and C there, these numbers here. So we know it's a division between those numbers. So you just need to be mindful that you might get an answer and it might look a little bit different to the person next to you, or to what your calculator says, or what a textbook says. You just need to understand that they can all be written differently depending on the log laws that are applied. And we've just got a last example here. Example 3, a group of 200 insects were monitored in a lab experiment and the population was found to grow such that the number n present t days after the experiment commenced approximately fitted the model n equals 200, open brackets, 2.7, close brackets, to the power of 0.1 t. Find, without a calculator, the day on which the population first exceeded 1,000. So what we need to do first is we actually need to write an equation that we want to solve. So I'm going to start down here because we might need a little bit more room. So we've got 1,000 is equal to 200 to the power of 2.7, times 2.7 to the power of 0.1 t. So the first thing we've got to do is we want to eliminate how many numbers we've got here. So the first thing we can do is actually move this 200 over to the other side, and it's going to become a division. So it would be 1,000 divided by 200, which is equal to 5. So we've got 5 equals 2.7 to the power of 0.1 t. So it's at this point now where we have to take logs of both sides. So I'm going to have log 5 is equal to log of 2.7 to the power of 0.1 t. And then as per usual, we're going to bring that power down to the front. So I'm going to have log 5 equals 0.1 t log 2.7. So now I'm trying to get the 0.1 t by itself. So to do that, if I have 0.1 t by itself, I'm going to move the log 2.7 over, and that's going to become a division. So it's just like normal equations, but we've got log involved. So we've got log 5 divided by log of 2.7. And then the last thing that we need to do is get rid of that 0.1. So dividing by 0.1 is the same as multiplying by 10. So if we multiply this by 10, it becomes 1t, which is what we want. But if I multiply that side by 10, I also need to multiply this side by 10. And remember, it would be multiplying by 10 over 1. So it's only the numerator that gets multiplied. So we end up with 10 log 5 over log 2.7. And then it would be, at this point, you would leave it like this if it was without a calculator, which it says in the question. But then if we were to actually find and want the exact day in terms of an actual number, we would get 16.2 if we typed that into our calculator, which is therefore it would be the 17th day that it first exceeds 1,000. So you're just using that non-calculator stuff to be able to do the logarithms. And the reason you would need to know how to do this in a calculator section is that if something's worth more than 2 marks, you do need to show that little bit of extra working out rather than just typing it into your calculator and solving it. So we can use the logs by taking the logs of both sides and then solving from there. Once we get down to that point, you would then use your calculator And your normal scientific calculator can work out a question like this, where we end up with 10 log 5 divided by log 2.7. A scientific calculator can do that. Whereas if we were using our graphics calculators in a 2-mark question, we would just do a solve situation and we wouldn't need to do all the extra working out. So hopefully this process is quite simple. Again, it is just looking at solving equations and applying all those same rules of solving equations, but you just need to make sure you take the logs of both sides first. And then once you've done that, you should end up with being able to solve a normal equation, applying those log laws, and again, practice, practice, practice.